What? Yeah, quadratic. Standard form. How do you find the vertex of a quadratic written in standard form? It's not as convenient as vertex form. If you remember, vertex form is y equals sum a times the quantity x minus h squared plus k. So if I gave numbers to that, if this was our vertex form, you can just look at that and tell me the vertex, right? We've practiced this. We go opposite this guy, same this guy. So the vertex would be, Andreas, what would the vertex be? Great, negative 3, 5. Vertex form is definitely more convenient, but it's not always written up or set up that way for you. Standard form looks like this. Oops, I am on the wrong page of my book. Let me get to the right page. Anyway, capital AX squared plus capital BX. Yes, sorry. Plus C equals Y. So my book's on the wrong page. That's going off memory. AX squared plus BX plus C equals Y. A, B, and C are numbers. A, B, and C are numbers. Yeah, it kind of looks like Pythagorean theorem, huh? A squared plus B squared equals C squared, but it's different. Okay, so in this case, an example of standard form would be like y equals negative x squared plus 4x minus 2. And the y can be on the right side or it can be on the left side. This isn't as pretty. Can you see the vertex right there? No, definitely not. Okay, in a parabola, we've talked about this already. For this guy, if our vertex is negative 3, 5, let's see, we go 1, 2, 3, 1, 2, 3, 4, 5. And the A was negative 2, so we know that it flipped down. If I use my ratio 1 over 1, with a multiplier of negative 2, I'd actually go down 2, right and left 1. Okay? I go down 2, right and left 1. And then I would go down 8, right and left 2. Down 8, 5, 6, 7, 8, right and left 2. And this is the graph of the quadratic in the vertex form. We talked about this vocabulary before. What's the thing right here that splits down the middle called? What? Line of symmetry? Okay, there's another word for a line, though. What? It does bisect, yeah, in the middle. Starts with an A, and there's an X in it. Axis of symmetry. This guy, this full line is the axis of symmetry. Kind of ran out of room. Sometimes we abbreviate it AOS. Notice it always goes through the vertex, and it slashes through the x-axis. So the x-coordinate of the vertex is your axis of symmetry. So if we can find the x-coordinate of the vertex, we know the axis of symmetry, or if we know the axis of symmetry, we can figure out the vertex. Okay, to find the axis of symmetry, we have a nice little formula. It's x equals negative b over 2a. X equals negative b over 2a. The b and the a come from the equation. This coefficient is your a, this coefficient is your b, this constant is your c. So for our example right here in standard form, what's the b value? Currently it is positive 4. When we find the axis of symmetry, we do opposite b, or negative 4, over 2 times the a value. Yen, what's the a coefficient? Negative 1. Great. Which would give us negative 4 over negative 2, which gives us 2. So the axis of symmetry is an equation x equals 2. KOS. It's an equation. It's not just 2. X equals means it's a line slicing through the x-axis, a vertical line that goes straight down through the x-axis, in this case at x equals 2. We can find the vertex by plugging in 2, because we know the vertex has an x value of 2. So to find the vertex, plug in the axis of symmetry. So all of the x's are going to become 2's. So here's my equation. Y equals negative, what do I put where this x is? 2. And when I plug in, a good habit would be put parentheses, because sometimes you're plugging in a negative, and so parentheses are definitely needed. Plus 4 times, what do I plug into this x? 2. Minus 2. Okay, you and your neighbor go through appendix. Please excuse my dear Aunt Sally. And using order of operations, you don't need a calculator, guys. You can do this by yourself using order of operations. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. Okay, fingers in the air. What did you get? Oh, I have different answers coming up. Uh-oh. Okay, guys, we're going to go through order of operations. Is there anything inside the parentheses to do? No, so we do exponents. 2 squared is 4. Then we do multiplication. Negative 4, because this is technically timesing by a negative 1, plus 8 minus 2. And then you add and subtract left to right. Negative 4 plus 8 is 4. Minus 2 gives us y equals 2. So the vertex is a point, positive 2, comma, positive 2. That's our vertex. Yeah? Yes. Yeah. Okay, I'm going to give you another one. See if you can find first the axis of symmetry. So this is probably example 2. Here's the standard form, finding the axis of symmetry, which then you plug in to the function to find the vertex. Y equals x squared minus 6x plus 4. Find the axis of symmetry and the vertex. Remember, axis of symmetry is x equals, it's not just negative b over 2a, it's x equals negative b over 2a, because it's an equation to a line or an axis. Okay, with your neighbor, work it out. When you think you have it, check with your neighbor, see if they got the same. You can when the bell rings. Okay, we should probably stop after we get the axis of symmetry, make sure everyone has the correct axis of symmetry before you start plugging in. What's the value of B? B is a negative. -6. So, guys, eyes up here, please. The numerator becomes a -6. It's opposite B, so a -6's opposite would be +6, right? So make sure you got a +6 up there. And 2 times, what's A? 1, so the axis of symmetry is not 6. The axis of symmetry is x equals 6. Use that, plug it in to find the vertex. What am I doing? Ah, okay, thank you. Like I said, not 6. Just kidding. X equals 3. Thank you, thank you, thank you. You know what they say about engineers and mathematicians? We can do the complex math, but we can't do the easy math. Make all our mistakes on the easy math. Okay, plug in wherever there is an x. You plug in that guy 3 and it pops out a y. Make sure your vertex is written as an ordered pair, x comma y. Not when you do the vertex. We use the C for something else later on. We'll learn that probably at the beginning of November. When you plug in, I recommend using those parentheses. Okay, fingers in the air. What's the y value you got for the vertex, the y coordinate? Fingers in the air, what's the y coordinate? Good. It should be -5. Because this is 9 minus 18 plus 4. Y is -5, so the vertex is 3, -5. Okay? You're going to hit a story problem. Say everything you need to solve a story problem. You know now. Here it is. Example 3, just write down on your paper the important information. You don't have to write down the whole thing. Write down the important information though. During halftime of a basketball game, a slingshot launches t-shirts at the crowd. Have you seen that done before? Yeah? When you launch something, what type of shape does the path of the launch take? An arc, so it's a quadratic. A t-shirt is launched with an initial upward velocity of 72 feet per second. I would probably write that down. The t-shirt is caught 35 feet above the court. How long will it take the t-shirt to reach a maximum height? Interesting. What vocabulary word do we know about quadratics that represents the maximum height of a quadratic? maximum, what is it? It is the vertex. Maximum height is the y-coordinate of the vertex. Would you agree that the y's are your heights? Y's goes up and down. So it's the y-coordinate of the vertex. What is the maximum height and what is the range? Talk about with your neighbor. How would you go about solving this? Did you give me back my book? Okay. Oh, thank you.
I'm gonna come in.
Is anyone in the physics class right now? Great. I'm sure you're a guy. Talk about your neighbor. How do you think you solve this? Here's a hint. Page 130 in your book. You have your books? Page 130 in the blue box. There's the physics equation we need. Page 130 in your books. It's in the blue box on page 130 in your book. If you're not familiar with the physics of launching something, page 130 in your book. Raise your hand when you know the equation we need. It's very similar to the ones we've been doing on the falling object quiz problems. H equals, who's found it? Page 130 in your book. Can you read it, Christine? Okay, so V is, sometimes you see it in physics as V naught. V naught means your initial velocity. What is C? This is, we've done story problems like this, dropping something off of a bridge, dropping something off of a roof. C is the initial height. At time T. So do we know V naught? Do we know the initial velocity? Yeah. Let's go 7 first. 72 T plus, do we know the initial height? Or when it's caught? 35, there's your function. Okay, now go and find the maximum height, which is the y-coordinate of the vertex. Then I also want you to write the range. The axis of symmetry gives you the x-coordinate, and you plug it in, and it'll give you the y-coordinate. Yes? Use that formula, negative b over 2a. Negative b over 2a. Oh, guys, I'm sorry. I made an error. This is not correct. That's when it's caught. That's the initial height. Look at the picture. What's the initial height on the picture? 5. That's what we need. My apologies. 5. Okay, we're nearly running out of time, so let's really quick go over it. What's the B? 72. The opposite of that would be negative 72 over 2 times what's our A? Negative 16. How do you notice we have that negative 16 a lot? Falling object problems always has negative 16 variable squared, t squared or x squared. When we're launching something, it's eventually going to fall, negative 16. Okay? So negative 72 divided by negative 32 is a positive. That's all I know. Help me out. You have those calculators, right? Does it come out perfectly? I don't think it comes out perfectly. Positive 2.25. That's your x-coordinate. How do you get the y-coordinate, which represents the maximum height? Plug it in. Plug in x equals 2.25, which is, the t is actually our x, right? 2.25, our x-axis in this case is time. And that would tell you your maximum height.